As I look at example number 3, I notice that it is not in standard form, so I need to move the 5 and the 2x over to the other side by subtracting them from both sides. And as I rewrite this, I want to make sure that I write it in standard form with my x squared term first. 3x squared minus 2x and minus 5 is equal to 0. And then I can start to solve. I don't have a greatest common factor here, so I can immediately jump to my x puzzle and write my a times c, which is 3 times negative 5, negative 15, and my b term is negative 2. So I'm looking for factors of negative 15 that add to be negative 2. That means that I have one of each sign, a positive and a negative, so that they multiply to be a negative. The negative number must be bigger because I have a negative 2 when adding. So I'm going to write my small term is positive, big term is negative. I have a 1 and a 15. The 15 is negative. I have 3 and a 5, and the 5 is negative. So the set of terms that's going to work in my x puzzle is going to be 3 and negative 5 because that adds to negative 2. So I can go ahead and write my solution to my x puzzle here. And then let's go ahead and draw our box. So our box, remember, has our ax squared term, 3x squared, my c term, which is negative 5, and then I need to write my factors with an x on them. So 3x and minus 5x. Let's go ahead and do GCFs. So 3x squared and minus 5x, just an x. 3x and a negative 5, well, those don't have anything in common except for, I guess, a 1. 3x squared and 3x have a 3x in common. Negative 5x and negative 5 have a negative 5 in common. Again, remembering that if you have a negative in this box, we need a negative on this particular term. Let's go ahead and rewrite our factored form over here. So I can write this as 3x minus 5 and x plus 1 is equal to 0. And our zero product property says that we can put each of these expressions equal to 0 and solve them. So 3x minus 5 is 0 and x plus 1 is equal to 0. I want to add 5 to both sides here, leaving me with 3x is equal to 5, and then I need to divide out the 3 that's currently being multiplied by x to leave me with x is equal to 5 over 3. This other one, I have a 1 that I want to move, so I need to subtract it from both sides, leaving me with x is equal to negative 1. All right, we've got one last problem before we move on to the next topic. I'd like for you to try problem number 4 and then come back here and see how you did. All right, let's walk through problem number 4. I notice that I need to get my equation in standard form by subtracting 18 from both sides, so I can rewrite my equation as x squared plus 3x minus 18 is equal to 0. Now I can do an x puzzle with a times c, negative 18 in the top, and my b value of 3 in the bottom. I need factors of negative 18 that add to be a positive 3. So I know since I have a negative when multiplying that I have one of each. I have a positive and a negative. Because I have a positive bottom term, that means that the positive needs to be my bigger factor so that they add to be positive. Once I run through my factors, I'm going to notice that the ones that make this x puzzle true is a negative 3 and a 6, because negative 3 plus 6 gives me that positive 3 that I need to solve my x puzzle. Let's write our box now. My a x squared term in the top, c goes in the bottom here, and then my two factors with x's on them, and then I do my GCF. I have an x, negative 3, x, and a positive 6. So I can rewrite a factored form by saying x minus 3 times x plus 6 is equal to 0. Remember now we can break this apart and use our zero product property to solve each of our small algebra equations. X minus 3 equals 0, which gives me x equals 3. X plus 6 equals 0, which gives me x is equal to negative 6 when I solve.